Encoder generates code. It generates code. So there can be octal to binary encoder, hex to binary encoder. There can be decimal to binary or BCD encoder. Encoder has many inputs, but out of that only one is active. One is active at a time. For example, keyboard. Encoder is commonly used in keyboard. There are many keys, but user presses only one key at a time. So keyboard, many, and the code is generated corresponding to active input. Corresponding to active input. So corresponding to active input, the code is generated by the encoder. So for every active input, there is a separate code. In case of octal and hex, the binary numbers corresponding, they are the codes. In decimal also, the BCD code can be the code. So if there are 10 keys 0 to 9 and user presses any one key, then the corresponding BCD number comes at the output. Now let us try to design the decimal to BCD encoder. So let us consider that in case of decimal to BCD, the inputs are decimal numbers. So decimal are the inputs. So when the decimals are the input, there are 10 combinations 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Any of the input can be there. And the corresponding BCD code, if you consider DCBA, will be corresponding to 0, it is 0, 0, 0, 0. Corresponding to 1, it is 0, 0, 0, 1. 0, 0, 1, 0. This is nothing but the binary equivalent of the decimal number. So 0, 0, 1, 1. In case of 4, 0, 1, 0, 0. In case of 5, 0, 1, 0, 1. In case of 6, 0, 1, 1, 0. 0, 1, 1, 1. For 7, for 8, 1, 0, 0, 0. And for 9, 1, 0, 0, 1. Once you know the truth table, where the decimal numbers are the inputs and the BCDs are the outputs, it is very easy to design the circuit because at a time only one input is active and other inputs are not at all active. So we have to consider 10 inputs. So these are the 10 inputs: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we must name them and we have to assume that for every input the key is connected. So keys are connected in this fashion. They can be in the form of a push button key. So this is a 0 number key. So exactly similar keys are here for every input. So whenever user presses the corresponding number, user has to press the key and then only the input will be connected. Otherwise it is connected to 0. It is considered to be connected as 0. So this is a key. And all these keys this side will be connected to plus 5 volts. So whenever the key is pressed, the line will become high. And it is expected that each key is connected otherwise through resistance to ground. It is expected. It may not be shown, but it is connected this way. Now we have to design a circuit. The outputs are 4 outputs A, B, C and D. So consider from the simplest case D. D is high only in case of 8 and 9. D is high only in case of 8 and 9. For all others, D is always 0. So you can see that D is 1 only for 8 and 9. So the simplest case is use an OR gate, because if 8 is high or if 9 is high, in both cases D will be high. All other inputs 0 to 7 are not necessary to connect to this OR gate because they don't affect the output D. So D is this way. Now let us consider for C. C is 1, C is 1, C is 1. C is 1 for the cases 4, 5, 6 and 7. So 4, 5, 6 and 7 will be the inputs of OR gate. So let us draw the OR gate in this fashion. A bigger OR gate which is having 4 inputs. It will generate the output C and it will have the inputs 4, 5, 6 and 7. So this will generate the output C. So C will be high only in these cases. So other inputs are not necessary to connect for that. Now let us consider B. For B again, observe that B is high only in case of 2, 3, 5 and 6. So inputs for B OR gate will be 2, 3, 5 and 6. Sorry, 2, 3, 6 and 7. So this is 6. 6 will be connected and 7 will be connected. So this will generate B. So whenever any of these keys will be pressed, B will be high. Now consider OR gate for A. A will be high under the cases 1, 3, 5, 7 and 9. So it will have 5 inputs 1, 3, 5, 7 and 9. So this will be connected to 1. This will be connected to 3. This will be connected to 5. 5 is where? 5. Let us take 5 from this side. 5. Then 7. 7 is coming here. So this is 7. And 9. The 9 is coming from this side. So this 9 will be connected here directly like this. So this becomes the circuit of decimal to BCD encoder. On the same lines, the circuit can be designed for octal to binary or hex to binary